I'm Frank Saylor, statewide maintenance operations engineer. This is Bill Flora, one of our area pavement engineers. We also have Clint Bryant, our highway maintenance director from the Crawfordsville District, here with us today, and Todd Shields, our statewide asset management engineer. I'm going to talk about expanding foam injection. This is something we just started doing, our maintenance forces. We have a lot of problems with drop slabs and some voids as well. A lot of times the problem comes up so quickly that we don't have time to get a contract in place. So this is a decision we made to try and alleviate some of the issues caused by this. This work is actually being performed by our maintenance personnel. We had training of them by our vendor. And then we had to purchase a bunch of equipment prior to that, right? So we've got a trailer to house and transport the equipment. We've got a, they call it a plural component, hydraulic proportioner pump. That's on the right there. That's a mouthful. Foam jacking gun is there on the left. Obviously, you need other pieces of equipment, air compressor, drills, drill bits. We have a generator. We have obviously hoses to get the product to the locations, buckets, trash bag, rags, etc. We are using, the material we're using is a 2-component structural polyurethane system. It's mixed at a 1-to-1 ratio. It weighs 4.5 to 5 pounds per cubic foot after it sets up. It has good compressive and tensile strength, 100 psi. It's traffic ready in 15 minutes, which works great for our maintenance forces. It's hydrophobic and closed cell after it sets up. It is certified for safe contact with drinking water. 1 gallon mixed material, half gallon of each component. It expands to approximately 2 cubic feet. We have various materials for pump maintenance. We have a pump flush, which is biodegradable, reusable, and has low toxicity. A pump lubricant, just a multi-purpose lubricant for pumps, pump protectant, again, oil-based protectant lubricant for pumps. We have a gun flush to clean them out, right? Biodegradable, zero toxicity, and water-based. And we have cleaning solvent, reusable, non-hazardous, and non-flammable. So one of the processes is selecting a slab, all right? It's recommended a maximum of 3 inches of settlement is all you try to lift. You lift more than that, you're probably going to put some forces on that slab that it is not capable of handling and cracking the slab. Obviously, slabs with distresses and corner breaks around the joints are bad candidates for this. There's some site constraints you have to be aware of. Pavement temperature needs to be 40 degrees Fahrenheit and rising. Subgrade should not be frozen, and you don't want any standing water. You'll be pushing on that standing water. It's going to be an issue. So, to lift a large slab, you start drilling holes at the lowest point through the slab, 12 to 18 inches from the joint edges, and you drill subsequent holes along that low edge, whatever that may be, at about 6-foot intervals. You drill another line of holes further away from that original line, because you're going to create, as you lift the slab, you're going to create a void, right? Just makes sense. So you're going to have to fill that void up unless you want it to bridge it. So you'll have to fill that up later, so you add some more holes. So then you begin injecting your material and monitoring the raising of slab with those dial gauges. Those are the little blue items, pieces of equipment you see there. So one of the things we've learned, if the dial on the gauge is moving clockwise, your slab is raising. Great. If it's moving counterclockwise, it likely means you're moving the adjacent surface that the dial gauge is resting on is being raised. Obviously, you don't put the whole gauge on the slab you're raising. That doesn't make sense. You should be monitoring the surrounding area during this process to ensure you're not raising adjacent slabs, materials and escaping out from under the slab and just losing it, or your filling items. We don't want to fill our culverts or inlets. It's especially important if you're pumping a lot of material. So there on that photo on the left, we had a slab to raise. It was less than 3 inches, pumped quite a bit of material. The slab was that we were raising was the portion with the white line. You can see a joint there, and it's probably hard to see there, but there's a crack. That's the adjacent concrete shoulder. which had a void under it. We didn't realize we were pumping material under that void. We ended up cracking that shoulder. So something, a lesson learned for us, things to watch out for. It's recommended to raise slab in approximately 1/4 inch increments. After you've raised it about 1/4 inch, you stop injection briefly to allow the foam to rise and set. And you then check the level of slab compared to your benchmark, either adjacent slabs, you have to have a string line, maybe you shot some elevations, whatever that may be. After the slab has been raised to desired height at the low edge, fill the voids, which we talked about earlier, formed by raising the slab in holes further from the edge. Again, you're going to be creating those voids as you raise the slab. On the photo on the right there, that was a reinforced concrete bridge approach slab that we raised. It was a full width slab, so it was 2 lanes and 2 fairly wide shoulders, not sure, 8 to 10 feet shoulders. So we had to raise the entire end of the slab away from the bridge. During the process, we were raising the slab, we heard a loud pop. And it's probably hard to see, but there is a hairline crack there, so we did crack the slab. It was more noticeable when it first occurred. When we finished filling all the voids and getting it where we wanted it, it turned into more or less a hairline crack. We will go back and seal that crack, obviously, but again, this occurs and you got to be careful with it. You can drill holes and lift smaller slabs. We've lifted some sidewalk panels. For those smaller ones, it's recommended to drill the hole in the center of the slab. Obviously, you have to go through the slab and begin injecting material. If one end isn't raising, you drill an additional hole in that area and inject the material to raise that edge. As you can see here on the photo on the left, actually, I think that slab was a little bit lower than that when we started, but you can see our dial gauge is there, and then you look at the 2 photos on the right where we got the top surface of the slab up to the elevation of the adjacent slabs. This was out on our Interstate I-74 out southeast of Indianapolis. Here's a sidewalk at the end of a bridge that's obviously fairly significantly settled. So we injected it and we raised it up, and if you look at the photo on the left, you can see how much it's settled. On the photo on the right, we've raised it to the level about the top of the wing wall there and to the slab that was actually on the structure. We also have used it for some void filling. This is a situation where we saw a sinkhole in our pavement, went out, found a void, so we're doing some deep injection. We put this metal hollow rod into the ground. We were pumping down into the void that's on top of this box culvert. There you go. So you can't hear it, but there was a guy in there saying, "Stop, stop." Well, it doesn't stop instantly. So we ended up with a little material in the slab. Not the end of the world. I don't know who gets to go in there and cut that out, but anyways. But it's going to be an effective fix, I believe, for this, because we obviously had a problem at that joint. The initial equipment setup costs, trailer pumps, hoses, etc., as you can see, a number of different things there, was about $75,000. To buy 100 gallons of material, 50 gallons of each component, is about $3,200. We have tried to point out is this may not be a permanent repair. If you don't fix the underlying issue, that's present, that's causing the voids or settlement, this process will not necessarily eliminate the problem. But we have situations, and we're going to be doing this here next week, where we're going to come in next year potentially with a contract, but we've got some slabs that need to be raised, so we're going to go out there as a temporary solution and raise these slabs. So we're getting quite a bit of use out of this at the present time. That's my portion.
Bill Flora with NDOT. I want to talk a little bit about network level FWD. Part of the problem with our pavement management system is that cracking, in the past we've always thought of cracking as being a good structural indicator. We kind of say that, well, if the pavement's cracked, it has a structural problem. But what we've found out is that really it's not always structural. It may be environmental. You may have a dried out piece of pavement surface, the top down versus bottom up cracking. Also, it's in the surface. We don't know really what's happening beneath that pavement. I know I haven't developed X-ray eyes yet to look at underneath the pavement, so we don't really know what's going on. And also, when we crack seal, we really can screw up our crack density when we figure that out, if we're using that as a parameter. And so really, cracking is more of a structural viewpoint. What we want to do is we want to use it as a trigger to determine the level and type of treatment that we may do. We want to develop a structural pavement quality index based on deflection or some of the other factors that we can pull out of it, such as CBR, structural number, K values, the modulus. Right now, we don't really have enough information to make prediction curves. But fortunately, from my viewpoint, pavement structure tends to deteriorate very slowly. So I think that the way that we're approaching this is we develop a program 5 years out. So right now we are looking at 2028 right now, and we're going to deliberate that program in February, but right now we are collecting FWD information on that, on those projects, on those candidate projects. And then we're going to use that to make a more informed decision as to whether or not a particular treatment will work well or not. We have collected 6 years of data, and one thing that right now what I'm in the process of doing is correlating and pulling together that FWD data with other condition data, contract data, and really start to see. One other thing that we should be able to have is we should be able to say if we have a good structural or bad structural pavement program. You know, do we really have the pavement structure? My attitude is if we have high deflections in the subgrade and combine that with rutting and or fatigue cracking, we probably have a structural problem in the bottom of the pavement. Now also, we are working with our pavement design because we use FWD we use MEPDG to design our pavements, and part of that is based on FWD information. And we need to balance network level FWD with project level FWD. We can collect the project network level early on, and then that may be suffice to design a pavement when the time comes. If we do need to get additional information, we'll go out and get it. Bottom line is we got to have a better way of defining the structural condition of our pavement. We are very fortunate in Indiana. We have a good number of FWD. This is all in-house testing. We are working with our maintenance people to set up traffic control, and we're working out those details right now. But this is really about the first or second year that we've done it. So we're looking forward to seeing how that might work out. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.